Here we have a problem from the LA City College 2007 math contest, and it gives us these two definitions for functions of f and g on ordered triples a, b, and c. What the f function does is it essentially switches the first two entries in this ordered triple, and what the g function does is it essentially rotates, so the last item becomes the first item becomes the second item, and the second item becomes the third item, as you can see here. And the problem wants us to find g of f of a, b, c. It wants us to find the identity in terms of f and g. It wants us to list all the possible one-to-one functions stemming from f and g, and then find the inverse of g. So let's tackle these one at a time. Let's find g of f of a, b, c, and this should be the easiest one. So let's see, g of f of a, b, c. Let's work from the inside out. F is given to us here, so that's just going to be g of b, comma a, comma c. That's just by this red dot right here. And I'll go ahead and label the g function with this blue dot right here. So now we just use the blue dot and we get a rotation of these items. So we get c, comma b, comma a. So that's great. That's the g of f of a, b, c. So we're done with problem A. This is our solution to that one. I'll go ahead and check this one off. Okay, now let's move on to question B, and that asks us what is the identity? And there's a couple of different ways we could do this. We could use f and g and some kind of combination, but I think the easiest way to do this is to look at what each of these functions does and do them over and over again until we find the identity. So if we take f of a, comma b, comma c, we get b, comma a, comma c. But that just switches the first two entries as we said. So if we take that again, that gives us a, comma b, comma c. So that's great. That's what we want to do here. F of f gives us what we input back out. So f of a, b, c gives us a, b, c back. So this is in fact an identity of this set of operations that we're working with up here. We can also use g. Let's go ahead and take that as an example. G of a, b, c is equal to c, a, b. But then if we took that again, we get g of c, a, b, and that gives us b, comma c, comma a. But then if we take that one more time, we get g of b, c, a, and that gives us a, comma b, comma c. And so what we've done here is we've taken this g function 3 times. So g of a, comma b, comma c gives us back a, comma b, comma c. Okay, so both of these things that I'm boxing in red here give us identities for this set of maps that we're working with. So let's check this problem off and move on to letter C, which I think is probably going to be the most extensive. Okay, so we've checked off letter B, and now we're moving on to this letter C, which tells us to list all possible one-to-one functions stemming from f and g. So what I think we should do here is take this ordered triple and find all the possible permutations, and then find combinations of f and g that satisfy those combinations. So let's see. Our combinations with a at the front are a, b, c, and a, c, b. And then we have, let's see, we have b at the front, that gives us a b, a, c, and b, c, a. And then if we have c at the front, that gives us c, a, b, and c, b, a. So these are our 6 possible combinations from this ordered triple permutation. But now look, we've already done a couple of these. F gives us BAC, so this one's done by red dot here. And G gives us CAB. So that one's done by this dot here. And then ABC we found, we can use F of ABC, or we can use G of G. That's what we did with this dark green check mark or question B. So we can check that one off. I'll go ahead and check that one in green to show when we did that one. But now that leaves these 3 remaining possibilities, and we did, I think, one of these along the way. And that was by taking the G function twice. So G of ABC applies 2 different rotations to this thing, which ends up giving us the ordered triple BCA. So we'll go ahead and mark that in orange here. And BCA satisfies this ordered triple here. So now we only have 2 more maps left. We need one that satisfies ACB and CBA. So how could we do that? Well, we could take this orange dot here and apply the F function to it to give us this CBA, because what the F function does is switch these 2 variables here. So if we take F of G of ABC, that gives us C, B, A. I'll go ahead and denote this with a purple dot down here. And that gives us this ordered triple right here. And now we only have 1 left, and I'll go ahead and use this space over here on the chalkboard to do that. And that's ACB. And I think the easiest way to do this one is to take 1 copy of G and then 1 copy of F. So let's go ahead and do that. That gives us F of G of ABC. But now if we rotate it once and then flip the first 2 letters, that gives us A, C, B. Because C would go to the front, B would go to the back, and A would come to the middle, but then the A and the C would flip. And I'll mark this in this dark brown color here. And this map gives us this triple right there. So now we found maps corresponding to all 6 different permutations of A, B, and C. So I'll go ahead and check off letter C, and we'll move on to the last one, finding an inverse for G. So now let's move on to letter D. And D tells us to find the inverse of G, but in a way we've already done that with this green check mark here, because we found that G of A, B, C is equal to A, B, C. But that means the inverse of G is just G applied twice. So this function right here that I'll color with a blue dot, and then I'll circle it in purple to show its relation to the original blue dot that we have up here. This is our inverse of G. When applied together, they give us the identity, which is exactly the definition of an inverse function. So when these 2 functions are stuck together, we get A, B, C back. All right, that's enough for now.